Hello, the objective of this video is to learn about polygons and how to find the sum of all their interior angles. First, we need to know what a polygon is. A polygon is a simple closed figure formed by three or more line segments that only cross at their end points. So let's take a look at some examples of polygons and some examples of things that are not polygons. Up here at the top, we have polygons. They're all enclosed, they all meet at their endpoints. Square and triangle should be some polygons you are familiar with. These are not polygons. This one right here crosses at a place that is not their endpoints. It crosses in the middle there, so that means it is not a polygon. This one is not enclosed. It has this opening right here, so it is not a polygon. Here we have this curve. If you got a curve, it's not formed by line segments, it's formed by a curve. Therefore, it is not a polygon, which would make a circle not a polygon. Now, we've been asked to classify different kinds of quadrilaterals, different kinds of triangles. When it gets larger in the number of sides than the quadrilateral, we tend to classify it just by the number of sides. Although there is a little twist, we'll get to that a little later. No, the number of sides. You have 5 sides, you have a pentagon, just like the Pentagon down in Washington, D.C. It's named the Pentagon because it has 5 sides. Hexagon is for a 6-sided. Heptagon, 7-sided. Octagon, octopus, 8, octagon. That's why it's called an octagon. 9-sided is nonagon. 10-sided is decagon. Deca. We should have heard deca from decameter, it stands for 10. Now, the 11 and 12 gons here, you may see them, you may not. I'm including them. They're not in your textbook. I especially like the 12-sided dodecagon, simply because it's just fun to say, dodecagon. The 11-sided figure is a hendecagon. But generally, once you get over a decagon, you start going with the number dash gon to describe it. So if you had a 38-sided figure, it would be a 38 gon. 38-sided figure would be a 38 gon. Interior angles. Now, we did a lot with interior angles on triangles. Now, when we did the triangles and rectangle and quadrilaterals, we talked about angles and how they all add up to a certain number. When I was talking about the angles, I was talking about interior angles. An interior angle is any angle that lies inside of a polygon. Equilateral. Now we know an equilateral triangle is one where all 3 sides are the same length and all 3 angles are the same length. But equilateral applies to any polygon. If a polygon has all sides that are the same length, it's considered equilateral. A square is actually an equilateral quadrilateral. Try and say that 3 times fast. Equiangular. Equiangular is all interior angles are congruent. So not only are the sides the same length, but the angles are the same measure and side. A regular polygon is a polygon that is both equilateral and equiangular. Square has all 4 90 degrees and all 4 sides same length. So it is both equilateral and equiangular. It is a regular quadrilateral or regular polygon. The rhombus would be equilateral, but it would not be equiangular. An equilateral triangle has all 3 angles and all 3 sides the same length, so it falls into the regular polygon category as well. All polygons can be cut into triangles. Now you'll remember when I did the triangle video, we ripped off the corners and we put the 3 corners together and they all added up to a straight line, 180 degrees. So we know there are 180 degrees in a triangle. Since Quadrilaterals could be cut to form two triangles. They had a total of 2 times 180, 360 degrees. A 5-sided figure can be cut into 3 triangles. Yes, you could actually cut them up into millions and millions and millions of little tiny itty-bitty triangles. But we're talking about cutting them up based on triangles that have the same vertices as the vertices of the shape itself. And we're looking for the minimum number of triangles you can make using the vertices there. The minimum you can make here is 2. The minimum you can make here is 3. And as it turns out, as you go down, 3-sided, 4-sided, 5-sided was 3 triangles. 6-sided you can make 4 triangles with. 7-sided you can make 5 triangles with. And since each triangle has 180 degrees, it keeps going another multiple of 180 degrees higher with each level of sides. So 3 you would multiply by a 3-sided figure gets multiplied 180 by 1. A 4-sided figure gets multiplied by 2. 5 gets multiplied by 3, 6 by 4. It looks like if we take this number, subtract 2 from it to get, which will give us the number of triangles that get formed by it, multiply that by 180, I'll get the sum of all the angles. And there's a formula that says just that. The sum of the measures of the interior angles of a polygon is n minus 2, number of sides, minus 2, times 180, where the n represents the number of sides. Don't forget, this needs to be in parentheses because you do need to do that subtraction before the multiplying. Order of operations, parentheses before multiplying. Algebraically, this is written as sum of angles is equal to n minus 2 in parentheses times 180. And you will find that on the FCAT reference sheet. Find the sum of the angles of a decagon. Well, here, let's try and find the sum of this angles here. The decagon. Decagon, we looked at earlier, is a 10-sided figure. So the number of sides is going to be equal to 10 minus 2 times 180. 10 minus 2 is 8. And we get out our calculator and we do 8 times 180, we're going to get 1,440 degrees. That is the sum of all the angles of a decagon. Much easier than having to draw a decagon and try and measure all the angles, add them up. You do. Here you are given 2 shapes. Find the measure of sum of all the angles of these polygons. Pause the video. Welcome back. A heptagon is a 7-sided figure. So it's going to be 7 minus 2 times 180, which would be 5 times 180, which is going to give you 900 degrees. This side, they didn't tell us how many sides, but this one, they didn't tell us how many sides, but we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 sides to that one, which means that I have a nonagon, and that would be 9 minus 2 times 180, which is 7 times 180. And 7 times 180 is going to give me 1,260 degrees. So that is the sum of the angles of that polygon. Warning! The following statement is for regular polygons only. Regular and regular polygons only. Which means that this statement is only true for those that have the same length. Every side has the same length and every angle is the same measure. The measure of a single interior angle of a regular polygon can be found by dividing the sum of its angles by the number of sides. this formula here might seem familiar. It's what we just got, n minus 2 times 180. That gives you the sum of all the angles. Divide by the number of sides, and you've got the measure of one interior angle. Since we're moving on to the next board anyway, let's take a look. Find the measure of one interior angle of a pentagon. Well, a pentagon is a 5-sided figure. So we're going to have 5 minus 2 times 180. That's 3 times 180, which is going to give me 540 degrees. That's the sum of all the angles. If I take that 540 and divide by the number of sides, which is 5, I'm going to get, what is that? I get 540 divided by 5, I get 108 degrees. So every angle on a regular pentagon is going to have a measure of 108 degrees. Since the pentagon down in DC is a regular pentagon, you're going to find that the measure of those angles is 108 degrees. Pause the video, give these next two a try. 15 gone means that it's got 15 sides, so you do 15 minus 2 times 180 over 15, which gives you 13 times 180. 13 times 180, I get 2,340 over 15. So if I divide that by 15, I get 156 degrees. Now here you have a stop sign, which has 8 sides, and that is a regular polygon. So we're going to do 8 minus 2 times 180 degrees, which is 6 times 180, which is going to give me 1,080 over 8. If I divide that by 8, I get an answer of 135 degrees. So each angle inside of an octagon has a measure of 135 degrees. See you in class.